Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, covering the entire syllabus for US Honors Chemistry, and I also offer one-on-one tutoring lessons, but the seats are very limited. If you need one-on-one tutoring lessons, so the Google form is given in the description. You can fill it out and I will contact you. You can also join my high school community, my chemistry community with the name of High School Chemistry on school.com, and the link is given in the description. I offer, like, it is free to join on that community. I offer one-on-one tutoring lessons. Group lessons are available 4 times in a month, once per week. So you can ask questions and participate in discussion forums and stuff. So it's a good place to be if you are studying chemistry or excited about it. So in this lesson, we will be talking about Lewis structures, and this is uh, very important topic for understanding bonding, covalent bonding, and how the like what is the basic structure of a molecule is. So Lewis structures, they enable us to understand that how many bonds can there be or will there be in between two bonded atoms, and how many lone pairs will there be, if any, on the atoms that are present in a certain compound. So you can pause this video here and you can read these rules, and once you read them, now I'll apply them one by one on certain molecules so that we can understand that how it works. So let's take a molecule, hydrogen cyanide, and the first rule says that draw a skeleton structure. Hydrogen and fluorine are always terminal atoms. So skeleton structure, you have to write it like this. Hydrogen can never be the central atom, so I'm writing it here. And then we have to choose which one will be the central atom. Will it be carbon or will it be nitrogen? So the rule says that the element with the lowest ionization energy goes in the middle, right? So with some exceptions, of course. So here, ionization energy, we have learned in our previous lessons that it increases from left to right. So, carbon will have a lower ionization energy as compared to nitrogen, because carbon is in group 14 and nitrogen is in group 15. So, and the trend is the same as electronegativity. So you can also, like, you remember this by electronegativity, lowest electronegativity. And if, let's say, two atoms are in the same group, for example, oxygen and sulfur, for example, so then the atom that is further down the group will be the central atom, right? So I hope this is clear. And so carbon I will write here, and then nitrogen. This is called the skeleton structure, where we give some space between the letters or the symbols of atoms, right? So the second rule is count the number of the total number of valence electrons, and if there is a negative ion, add the absolute value of total charge to the count of valence electrons. If positive ions, subtract. But since we are dealing with a neutral, like, compound, we are not dealing with an ion, so we just count the number of total like valence electrons, and we will see another example where the rest of the rule can be applied. So hydrogen is in group 1, so it will have one valence electron. Carbon is in group 14 or group 4, so it will have 4 valence electrons. And nitrogen, it is in group 15, so we have 5 valence electrons. So if you don't know how to figure out the number of valence electrons in an atom, so you go back, watch my video on chemical bonding and the periodic trends, so you will understand this. So now we add these all up, and we get 10. We have 10 valence electrons, right? And now the next rule says that count the total number of electrons needed. So you can change this by saying that count the total number of electrons that can be accommodated in for each atom to have a full valence shell. So hydrogen can handle 2 electrons in its first shell. Carbon can have total of 8 electrons. The maximum number of electrons carbon can have in its outer shell is 8, and same is the case with nitrogen. So 8 and 8 16 and 2 18. So we have 18 total electrons needed for each atom to have a full valence shell. So I hope this is clear. And you don't do this that okay, one electron is already there, so it will need one more. So don't write the difference, just write the maximum that the outer shell of each element can hold, right? I hope I've made it clear. And so now we go to the rule number 4. It says subtract the number in step 2 valence electrons from the number in step 3 total electrons for full shells. The result is the number of bonding electrons. So it's going to be 18 minus 10. So we get 8. That's our bonding electrons, right? And now we assign so rule number 5. So let me just write, this is rule number 1 where we draw the skeleton structure. This is rule number 2, we are counting the valence electrons. This is rule number 3, we are counting the total electrons needed. This is rule number 5, where we calculated the bonding electrons. Now rule number 5, assign 2 bonding electrons to each bond. So I assign 2 bonds between hydrogen and carbon, and 2 between carbon and nitrogen, right? Now it says that if bonding electrons remain, make some double or triple bonds. In general, bonding double bonds form only between carbon and nitrogen, oxygen, and sulfur, and triple bonds are usually restricted to carbon, nitrogen, and oxygen. So out of 8 bonding electrons, we have assigned 8, right? Sorry, 4, and now 4 are remaining. So the remaining electrons will be assigned between carbon and nitrogen. So 1, 2, 3, 4. So that is it. And at this point you should know that whenever 2 electrons are shared between the atoms, so it's a single bond. So it's 2 electrons, it's always 2 electrons per bond, right? So if it means that if 2 bonds are shared, it will be a single bond, right? If 4 electrons are shared between the 2 atoms, it is going to be a double bond. And if 6 electrons are shared, so that means that it will be a triple bond, right? So here between carbon and nitrogen, 6 electrons are shared, so that is a triple bond between carbon and nitrogen. So okay, now we have applied rule number 6. This is rule number 6. 5 and 6 we assign simultaneously, and then we move on to rule number 7. It says that if valence electrons remain, assign as lone pairs, giving octets to all atoms except hydrogen. So here we can see that we started with 10 valence electrons and we assigned 8 electrons, right? So 10 minus 8, and that's gonna give us 2. So these 2 electrons will go as one lone pair, and you can see here now that hydrogen has a complete duplet. It has 2 electrons in its valence shell, and it cannot handle more than 2 electrons. So hydrogen cannot get the lone pair. Similarly, if we look at carbon atom, so carbon has 8 electrons around itself. So its octet is complete: 1, 2, 3, 4, 5, 6, 7, 8. So the lone pair cannot be assigned to the carbon atom. So the lone pair will go to the nitrogen atom, because you can see that it has only 6 electrons in its outer shell. So these 2 electrons cannot be counted for nitrogen. Remember that these are only shared between carbon and hydrogen atom, right? So the octet of nitrogen is still incomplete, but when we assign these 2 electrons as a lone pair, so now that completes the octet of nitrogen, and that is the Lewis structure of hydrogen cyanide. We have one bond between carbon and hydrogen and carbon, and we have a triple bond between carbon and nitrogen, and we have a lone pair only on the nitrogen atom, and we don't have lone pairs on hydrogen and carbon. So this is how we apply the Lewis structures. Now let us apply on cyanide ion, Cn negative. So you can pause this video here, and you can um, you know try to apply these rules on a cyanide ion, and let's see how it works. So now I'm going to draw the cyanide ion. So step one, uh, count the skeleton structure. So here only we have only two atoms, so it doesn't matter. These skeleton structure arises when you have more than two atoms involved in in a certain compound. So yeah, so the next rule is that count the valence electrons. So we have 4 and 5. So 5, 6, 7, 8, 9. And but the rule says that if it's a negative ion, you add the total charge in the valence electron. So it has one negative charge, so I'm going to add 1. So that makes us, so that makes it 10 valence electrons, right? Electrons. And yeah, so now the total number of electrons needed or can be accommodated in hydrogen and nitrogen, so it's 8 and 8, so it's 16, right? So now bonding electrons, 16 minus 10, that's going to give us 6. Okay, so now we have only two atoms, so all 6 bonding electrons will be distributed between the carbon and nitrogen. So I'm gonna add these. So 1, 2, 3, 4, 5, and 6, right? And now so this is yeah. And now let us calculate the lone pairs. So we started with 10 electrons, and we assigned 6 out of 10 valence electrons. 6 were bonding, so now we have 4 remaining, right? So we have 4 electrons that will be assigned as 2 lone pairs. So now this is going to be one on each, right? So 1, 2, 3, 4. Yeah, so now when we assign one lone pair on carbon and the other one on nitrogen, so the octet of both atoms are complete, and that is the Lewis structure. So I'm going to enclose this in a bracket. So carbon triple bond, nitrogen with a lone pair, carbon with also with a lone pair, and outside the bracket it's a negative charge, right? Okay, so now uh, yeah, that is it. That is the Lewis structure of cyanide ion. So we didn't talk about the formal charge. We will talk about formal charge in our upcoming lesson on Lewis structures. This is part 1. So it's a 3-part series where we, in the first lesson here, we get familiar with the Lewis structures. How do we apply them? In the second and third part of this series, we will talk about the special cases where Lewis structures cannot be applied or the octet rule is violated. And then we will also understand that what formal charge is and what is resonance, right? And how for a formal charge helps us verify our Lewis structure, whether our Lewis structure is correct or not, right? So all these very important topics, they will be in our upcoming lesson. So for practice, you can draw the Lewis structure for carbon dioxide. You can draw it for water, right, and ammonia. So you can draw these, and let me know in the comments that how many bonds will there be between these atoms, and how many lone pairs will there be on the atoms. And yeah, in our upcoming lesson, I will solve these molecules, and then we will take a look at the special cases and formal charge. All right, so I hope this is clear, and this will be all for today. And I would like to remind you guys again that like, subscribe, and share. And if you need one-on-one tutoring lessons, contact me on Google Form or School Community. uh, and yeah, I'll see you in the next one. Take care. Have a good day.